Hello and welcome back to another episode of Feather News. It's the 14th of August and let's get started. So, first of all, does OpenAI have a new rival? New startup AI21 Labs has released a 178 billion parameter language model to rival that of GPT-3, which is 175 billion parameter models. It's not the first GPT-3 re-implementation, there have been many around, but these guys explicitly make it a point to want to claim OpenAI's dominance as natural language processing as a service. Now, their model architecture is similar to GPT-3. However, they train and they use a different tokenization strategy to modify the way that their vocabulary is built, training on 256,000 tokens versus the 50K that GPT-3 was trained on. They also use theoretical guidelines to find the optimal depth for the model, reducing the number of layers from 96, which is what's used in the largest GPT-3 variant, to 80. Now, because of this, they gain a slight increase in training time, but more so about a 20 to 25% increase in inference time, which is pretty significant. And their models, which they dub Jurassic, support fine-tuning as well, so they can work with multiple different ranges of NLP tasks and build multiple different applications. One of these applications that they build is called WordTune, which allows the rewriting of text into a different tone, i.e., I can input a sentence and have it reworded into a formal tone or a casual tone. They also released AI21 Studio, which is free to play around with. I'll link them down below. Guys, check it out. It's pretty cool what they're offering. And a small number of examples that this language model can be used for could be classifying news topics, giving ideas about blog posts, answering questions based on a tabular input, and writing product descriptions. Secondly, we have a neural network that can think, and this was released by DeepMind, a model that they call PonderNet. Now, PonderNet is a neural network which can innately process an input n times before returning its prediction. And actually, architecturally, it's kind of simple. It requires an encoder to predict a binary valued lambda. Now, when lambda equals 0, the network will continue to recurrently process the input. So for the n steps while lambda is 0, the network will output a new predicted hidden state, a predicted y, and a predicted lambda. Now, once this network predicts a lambda of 1, we know to halt, and the y obtained for this step is the y used as the network's prediction. And PonderNet has showed impressive results on reasoning tasks such as parity prediction and the synthetic dataset Babi. Now, this is a long-standing dataset which memory networks have typically tried to tackle. PonderNet actually manages to do it very well with an architecture, with a transformer-based architecture. And the long-term applications of this could be multi-hop QA or multi-hop logical reasoning, and also open domain question answering on Wikipedia data, where perhaps you can click through into some of the links on Wikipedia to find out more information, which is what's required to answer the question. Thirdly, Facebook released Unidentified Video Objects, which is an extensively annotated object dataset for videos. And the annotations here are just the segmentation masks of the videos. Now, typical object detection or segmentation approaches are closed world, and closed world in the sense that the object vocabulary is limited, and thus they can only segment objects in their vocabulary. Now, using Kinetics, which is a video human-oriented action recognition platform, action recognition dataset, the researchers managed to use a semi-automated pipeline to segment all the objects in a video, reducing the typical time to label a video with segmentation masks from about 45 minutes to between the 10 and 15 minute range. And it's a big improvement in the sense that previous similarly segmented video datasets only had about an average of 3 segmentations per video. Whereas with their labeling strategy for unidentified video objects, FAIR managed to get about 12 segmentation masks for a particular video. And this is really exciting because it paves the way for future work such as object search and instant registration, and also more complex prediction tasks for videos ranging beyond the simple classification aspect, such as learning about the relationships between the objects in the video. Now, OpenAI have released a new version of Codex, which, if you didn't know, is a technology that powers GitHub Copilot. Codex is built on GPT-3 and it's trained on natural language data and also millions of GitHub repositories. And now Codex can interpret simple commands in natural language and execute them based on a user's behalf. And I think this is pretty cool because this example I'm showing you here, and obviously I'll link more down below, this example I'm showing you here manages to do a matplotlib for you and also does the extra work, which I find it such a headache to constantly have to Google Stack Overflow links, look at their documentation. If I had a tool like this, it would save me so much time on analyzing my data. So I'm excited to work with this as well. It's going to be a big time saver. Now, lastly, we have visual feature hierarchies with transformers. Now, hierarchical representations are a key component of the way that the human visual input system works. And with regards to machine learning, they've also been a key component to the success of CNNs by inducing this inductive bias within the CNN architecture. Now, Facebook bring this inductive bias to vision transformers, and they release MBIT, multiscale vision transformers. So how this works is that we'll have an input which is segmented into regions, and we'll feed these regions into a transformer. Now, the transformer will process one of the blocks, and then it will scale the input. And then once again, we can stack this multiple times. We can stack it n times to have an n-scaled version of the original input. So we will have, as we have in a CNN, we'll have a deeper channel representation, but we'll have a smaller height and width representation as well. And MVIT acts as kind of a pre-trained vision model, which achieves state-of-the-art on video understanding tasks such as action recognition, video classification, and also works for image tasks as well, such as object detection. Now, more work is needed to actually utilize the full benefits of what MBIT can enable. However, it can significantly improve detailed human action understanding, which will be a crucial component in real-world AI applications, such as robotics and autonomous vehicles. So personally, I'm very excited to see what comes from this nifty little architecture as well. Anyway, that's all from me. I hope you've enjoyed this update. If you want a way to share, deploy your models, your machine learning models, then check out feather-ai.com. And if you want to join an active community of machine learning enthusiasts where we run weekly community talks, then also check out featherai.com/discord. That's all from me for this week, and I'll see you guys next week.